And so for 13, we got a 40-year-old man has 432,860 in an IRA account. He decides to make no additional contributions to the account, but expects it to grow at 7.5% compounded annually. So let's talk about that first part of this for a moment. An IRA is a form of an annuity. And what happens with an IRA is you just make monthly or semi-annually or whatever, usually it's monthly contributions to it, which makes it an annuity because it's receiving regular monthly contributions. He decides to stop making contributions to the account, but expects it to continue grow, compounding annually. He wants to know how much he can expect to have in the account when he turns 62. The next question is, how much would he have had in the account if the investment earned 8.5% interest rate? And lastly, what would the impact of pushing his retirement back to 65 have? How much more would the account earn in the short period of just 3 years? So instead of pulling it out at 62, pulling it out at 65. Let's take a look. And so he has $432,860. And he decides to make no more payments. He expects to grow 7.5%, so rate is 0.075. Compounded annually, so M is 1. T is going to be from 40 to 62, so that's 22 years. He'll leave it in there. I is R over M. N is MT. So I is 0.075 over 1, so 0.075. MT is 1 times 22, so 22. And so our formula, we would have S equals R times 1 plus I to the power of N. We don't know the future value. We know he's putting in, or he has accrued, $432,860 into this account so far. 1 plus I is 0.075, and N is 22. So giving that to Wolfram, we will have 432,860 going into the account. 0.075 is the I, and N is 22. And so the results here, everyone, we have a times 10 to the 6. That's going to put it into the millions. So the future value of this is going to be $2,124,876.38. So the account will be worth, holy macaroni, $2,124,876.38 in 22 years. And good on this guy. Boom. Okay, our next question. How much more would he have earned if his investment earned 8.5% compounded annually? And so that was part A. For part B, I'm not going to do the SERM10 again. I'm just going to say that the rate this time is 0.075 because 0.85 because everything else is the same. So S equals R times 1 plus I to the power of N. And I guess it will change how the R, the I, that will also change I. R over M, 0.085 over 1, so 0.085 for our I. I'm just going to take a moment, everyone, and move this stuff over to the side so it's not so crowded. There we go. And I've got S equals 432,860. So again, the same investment. We're just testing a different interest rate, 0.085, and also for 22 years. And so all I've got to do in Wolfram, everyone, is just change that number right there to be 0.085. We'll see what kind of an impact that small change in interest rate would have on his investment. So that changes it to be 2.6 million, 2,604,963.81. 82 cents. My bad. I rounded wrong. Okay, so the account would be worth, we're asked how much of an impact that would have on it, so it's about $500,000. That's wild. So a change of just 1% in interest rate would have a end result for this man of a difference of $500,000. Interest rate is a big deal, everybody. I hope if you choose to make investments, you get a good interest rate and that our economy does well. That's why the strength of our economy is such a big deal, because if our economy is not doing well, interest rates are not good and people are not making money. So what would be the impact of pushing his retirement back to age 65? And so again, we're going to go with the first one, so a 7.5% interest rate. And we would say that instead of 22 years, it's going to be 25. So I'm just going to copy what I had up there and change that to be a 25. So I've got S equals R times 1 plus I to the power of N. My S was equal to 432,860 times 1 plus I was R over M, which was 0.075. Again, using my first interest rate, not the 8.5%. We're going to change the time to be 25 years. Let's do that on Wolfram. Make sure we change this back to 0.75. And we end up with 2.6 million, 2,639,727.28. So if we compare this value to this value, working for 3 more years gives him over $500,000 more. Isn't that nuts that the value of this investment grows by $500,000 in just 3 years? And what's causing that, everyone, it's been in the account for a long time. So as we said multiple times, the longer money is in the account, the faster it grows. He gains about $500,000 in 3 years. And just for giggles, everyone, because I'm thinking about it, let's say that he didn't need the money when he was 65. He was able to make it and not have to withdraw from this account until he turned 67. Let's change that number to 27 and see what happens in just 2 more years. So in 2 more years, it grows to $3,050,000. And so the value of this account goes up by almost $400,000 in just 2 years. As I've said multiple times, everyone, this is how rich people get rich and how you build generational wealth in your family. Money invested doesn't have to start off being a gigantic amount, but money invested for a very long time. I hope you enjoyed this problem.